Let's suppose that I wanted to calculate the square root of 69, alright? The calculator says it's 8.3066, but let's suppose that we didn't have a calculator. So how would we calculate it? Well, I mean, you know the square root of 64 is 8, right? And 64 is less than 69. But you also know that the square root of 81 is 9, and 81 is greater than 69. So the square root of 69 is probably between 8 and 9. But it's a pretty terrible estimate, honestly. Because clearly, the calculator says it's clearly closer to 8. So how can you get like a good estimate? Like maybe with a couple of decimal places, right? How do you do that? Well, I guess we should step back a little bit and think about it algebraically. So when we're trying to estimate the square root of 69, we should use a point that we already know, right? We know that the square root of 64 is equal to 8. So we should probably use this information. So if we consider the function y is equal to the square root of x, I think what we should do is that we should use a little bit of calculus, alright? We'll take the derivative of this, and you'll see why we're doing this. So dy by dx, if you know them derivative rules and whatnot, is 1 over 2 root x. This is the actual looks horrendous. Let's fix that. So dy dx is 1 over 2 root x. Alright. So when x is equal to 64, right, this is the x value that we know. When x equals 64, dy dx, or the slope of the tangent line to the curve, is 2 root 64 is equal to 1 over 16. Because let's think, root 64 is 8, 2 times 8 is 16, and 1 over 16. Alright, makes sense. So dy dx, the slope of the tangent line to the curve at x equals 64 is 1 over 16. So knowing the slope at x equals 64, we could say pretty crudely that delta y over delta x at x equals 64, at x equals 64, delta y over delta x is equal to 1 over 16. So the key difference here is that dy dx is some infinitesimally, whatever, but that's a big word. Over here, dx is just a really, really small number. Here, delta x is kind of a large number, like 1 or 2 or something, right? This is why it's a crude estimate. Here, dx is like 0.00000000001. It's really small. But this is the crude estimate we have to make in order to have a delta x of about 5 away from 64. So basically what this is saying here is that the macro scale slope, I guess, if you want to think about it like that, at x equals 64 is 1 over 16. So if delta x, if we move 1 away from 64 to 65, y is going to change by about 1 over 16, right? So delta x is 1, delta y is equal to 1 over 16, right? If you move to x equals 65, y goes up by 1 over 16. I think I've said enough about that. So think about this, at x equals 64, if we want to go to 69, right, x equals 69, delta x is going to be positive 5, right? Which means that delta y, the amount that y changes by, is 1/16 times 5 is equal to 5 over 16, right? So at x equals 64, y is equal to 8, right? So if we move a delta x of 5, delta y increases by 5 over 16. So our actual y value is about 8 plus 5/16, right? Because 8 plus delta y, 8 plus 5 over 16. I think I'm saying this really a lot of times because I forgot the last time I said it, and I think I didn't say it at all. Anyway. So y, our guesstimate for y is 8 plus 5 over 16, or 8 and 5/16. Now, I mean, if you know your fractions, right, know your decimals, know your fractions of 16 and whatnot, you'll say, or you can really easily calculate this to be 8.3125. And that's our guesstimate for square root of 69, right? So that's our guesstimate for square root of 69. If you look over here, this is the calculated value of square root of 69, 8.3066, right? So 8.3125 versus 8.3066, not much of a difference, and really should be sufficient for any needs that you have of the square root of 69. Mostly it's going to be entertainment needs, but whatever. Yeah, so pretty cool, interesting way to use calculus to guesstimate stuff. And I'll see you in the next video, whenever that happens to be.